Hey. So this is Katrin. This part was done together with Dana, but you will only hear my voice. So yeah, so it's submission best practices for different data types. And so the first part is basically a summary of reminder of what we have already, or what you have already learned so far. So basically when to submit data, what and how to submit data, and where to find information, templates, and other types of help. So you should have, you probably have memorized it already, but the question of when to submit your data is as early as possible. So as soon as your data set is complete, and that includes your metadata. And so the latest is when you submit your manuscript related to your data set, but often enough, there are data sets that are standalone without the manuscript. So please submit that as early as possible. And always keep in mind, moratorium is an option, so you don't have to be afraid that someone else is stealing your data. So what and how to submit data? So it's not only the actual data, but it's the data that's describing your data, which is called metadata. So it's all about the metadata. So let's focus on that for a bit. No, wrong direction. So metadata, as I mentioned before, is descriptive data about your data. So that actually gives context, and data without context is useless. So remember that your data is going to be archived in a fair way. So that means that there's a strong focus of what, who, where, when, and how it was achieved, the data. So, and the next part is focusing on the I and the R, the interoperability and reusability of your data. So there is metadata on different levels. So let's assume there's a single data point. For example, it's 3.14. Without any metadata, this could be anything. This could be a temperature, this could be average number of persons in next door, or it could be whatever. So therefore, don't forget to give metadata, the what, the where, and the when. So so then let's assume you not only have one single data point, but you have a whole series. So it's either a time series or it's a data series of one individual parameter. Then you can give additional, or this needs then additional metadata of which method or which device was used to achieve the data, and also who's responsible, who's the PI. And then it's very likely that it's not only one data series or time series, but it's a complete data set with several variables or parameters. And therefore, there is further metadata. For example, if some complex device was used, then it's usually more than one person that has acquired the data. There might be reports on how the data was achieved, and or additional information about funding, projects, expeditions, and so on. And the important part here to remember is that so it's not, we not only wanted the metadata to have a big and good description, but it's important that because the data is then searchable on every of these metadata levels in PANGAEA. So that's the important part about the interoperability and reusability. And so the data warehouse has already been mentioned. So that's a tool for data aggregation. And when you get the slides afterwards, you can simply click on the link and find out what it is, or you come back for the next community workshop in spring, where we will talk about it in detail. So let's have a look at examples and how the metadata is structured for these examples. And there are basically three different types of data structure. So it's tabular data, binary data, and collections. So let's start with an example of tabular data. So here it's field measurements, and it's data from a thermoselenograph. And this is actually what the data looks like. So you have the parameters long. So here it's a short name, but there are the units already, and there are some comments. And so if you hand it in like this, then the final publication will look like that. I know it's really small print. What I like you to notice is that there's not only the data, but there's this whole other bunch of information, the so-called metadata. So there is the actual data at the very bottom. There is another table, which is called the parameter table. So this contains information on the method and the device that's used and the PI. So there's info on the authors, and if it has been done during an expedition, also the expedition. So that's in the main citation. And there is a lot of other additional data. So in this case, there's an abstract comments, there's information. So here are different reports that are linked. Also, this report so it's only stored at PANGAEA, but there's other reports like the standard operation procedure, which is stored at Zenodo. So there's a link to the other repository. There's further details in terms of there's another small data table, which is also incorporated in the original data, but to make it simpler to just focus on them, there's additional file, there's project information, and there's information about events. So you should have heard the name event already, but it's actually, so if you're not familiar with this term, it means that this is a description of the device used. In this case, the device is a thermoselenograph, and this event describes that where and when it has been used during this cruise. So let's focus on the parameter table and what types of metadata is in here. So there is the parameter long name and short name, and the unit. So that's the what. There is a geocode. So that's giving you the where and the when. So that's here in date, time, latitude, longitude, and depth. So the geocode needs to have 3 dimensions because, well, simply from the parameter name, you know that it's the temperature of water. So it has to be somewhere below sea surface, but you don't know exactly where. So therefore, you need the 3rd geocode, the elevation or depth that tells you where the temperature was measured. So the principal investigator in this example, it's always the same person for the whole device, but this can actually vary if you have parameters from different devices, and then listed here. And the methods and the devices linked to this thermoselenograph are then listed in the yellow part. So this is the other metadata. So here again, the abstract that you can see that there are different reports linked to it, the events, and so on and so forth. So there is obligatory metadata. So it's the time and the location needs to be in 3 dimensions of the measurement. It's to know the device or the method that has been used to acquire the data, the author and the principal investigator, and some description in the abstract, or sometimes there is additional data description, for example, about quality flags. And then there is additional metadata, which is not obligatory, but it's a big bonus, and this big bonus improves the A and the R in fairness. So sometimes there are already events available. For example, if your data was acquired during a cruise of a German research vessel, then there is very likely an event list. If there is no such thing, then we can create one. So there's additional metadata on projects, funding, related publications, reports, and also related data sets. And the important part is that the traceability of the origin of the measurement and the analysis procedure is given. So we have on our wiki pages, we have one best practices page, and there are several templates. So there is a general template in 2 different formats. So if you're an Excel fan, you can get it in a spreadsheet template, or if you prefer to work with text files, then there's also a text file template. And this is a very generic one, but you can see already that there is a long list and it's not complete because it doesn't fit here of different research domains. So pick and choose whenever fits your data best. So if you have laboratory experiment data, then this example might be of interest to you. Here is again the data table. And as you can see right now, there's actually no latitude and longitude given. So that looks a bit funny, but let me explain this. If we have a look at the parameter table, then you can see this too, that there's only one geocode, and that's a date time, and that's the date time of the experiment. So, but we need to know when and where the samples that were used for the experiments, where they are coming from, and that information is stored in the so-called events. So here's an event label in your parameter table. So all this information is there that you exactly know during which event the original data or water sample has been taken. And there is then the latitude, longitude information and the date time information. And also here is the third geocode, the water depth. And then so the whole set of your geocode is complete. So the obligatory metadata is not only the time and location of the measurement, but also the time of the experiment. And then again, you need the device or the method and the authors and the data description. Plus, if you have them, all this additional metadata, and this is to ensure the traceability of the origin of the sample, plus the time passed before the use in the experiment. There's also a specific template for this one. This laboratory experiment can be found in the biology part of the PANGAEA Best Practices wiki page. So there's again a template and more examples. So there's another type of tabular data, and this is a literature compilation. And this is a rather long data set. So you can see here the number of parameters, and that I've cut out the big middle part. What I like to focus on here is that that we have the references in several ways. So there's an internal reference ID, there's the full reference, and there's a persistent identifier for each of the references. And so this is special and very important about this type of tabular data. And it's very important that you give a complete list. So you have the time and locations of your measurements. Plus, it's very important that you give all the references, not only of literature, but also of data. And you need to give them in full with a DOI. And that list is in your data table, and it will be then appear additionally as an extra list of references in the metadata part. And this is to give a traceability of the origin of the measurement and to credit the original work. This is actually very important. There's not a very specific example or template for a literature compilation because you can use actually either or any of our templates, and you add another column or columns for references. Yeah, so a different type of data, so that has a different type of structure of data, is so-called binary data. So everything that's basically not tabular data is called binary data at PANGAEA. In this case, we have an example of image files. So this would this is a part of the actual data, and what you can see, there's again geocode, and so the where and the when, and plus the link to the image and some additional text file. So also these type of data have a parameter table. As you can see, there is a geocode and also the principal investigator. What's missing right now in this table is the method device, but that one is described in the event related to this data set. So it's all there. So in this example, we have again our obligatory metadata. So the 3D geocode of where the image was taken, the device and the method is mostly listed in the abstract or the event. And again, you need the author, the PI, and a data description in form of an abstract. And this is to inform or to make sure that there's a traceability of the time and the origin of the image. So we have also templates for binary objects. And here it's not only that there is a list of templates, so there's actually a list of different types of templates for photos, images, for netCDF files, or for example, raw CDD files. But there's also a description about events. And if you'd like to, if your event is not there in PANGAEA yet, then you can also use an event template to give all that information and upload it to PANGAEA too. So there's another example of binary data, which is actually very similar, but this time it's raw data format. And the big difference is that it's now a different, it's not images, but it's a different set of data in different formats. And so there is an additional column which explains the content of the files. So if you have raw data format, then we need an additional description of the file content. So, and again, this is to ensure the traceability of the time and the origin of the measurement. And so you can use the same templates, or there's especially a template for, in this case, it's CDD file, raw CDD files, but it works with any other files. Okay. And there are the collections that Dana, for example, mentioned them already. And here is one example of a so-called publication series. And so the metadata part looks the same, but there's a parameter table is missing. And instead of that, you have a list of data set belonging to this publication series. And then if you click on any of these, you get a standalone data set on itself. So that then looks exactly as you expected. So there is the normal metadata and the parameter table and the actual data table. So the structure of these types of collections, in this example, it's a publication series, is that you have one data set that's basically the parent. So it's describing all the other sets that are listed there. And each individual data set is called a so-called child data set. And what's important that if you are submitting a collection, that each data set, including the parent, needs complete metadata, and each data set, also including the parent, has an abstract. so that each of the data sets can be dealt with as a standalone data set. So where to find information and help? So that has also already been mentioned that there will be authors guides. Those are coming soon. So there is the wiki pages of PANGAEA, and there are some subpages, for example, best practices or the data submission. There is the contact us button, where you can leave a message, or if you have already submitted data, then you can keep in contact via your ticket, and you can also ask more questions, or if you have comments or anything else, you can do that even after the ticket got closed. Yeah. So that was a theory part. Now we have a practice part to help you check the data before you submit it. So we have created a data curation checklist in Python, and I'm going to show you that example in Python, but we also have it in R. They are both in the GitHub repository, so you will get the link. I don't know, somebody might paste it in the chat right now. Otherwise, you will get it afterwards. So both examples are here, but if you click on this one, you will be redirected to the one in Python. Interesting. There's just a black screen on that I see. So it used to be here, slowly building up. So usually that's really fast, but not this time. So here we go. So in GitHub, there's the community workshop material repository. So it's free for everybody. So you can go there and click and see what's there. And in the directory of Python, you will find the data curation checklist. If you're looking for the same in R, then go to the directory called R. So in this, there are several ways you can use the data curation checklist. So you can either go here, click on this link, and you will download it. It's in the format of a Jupyter notebook, and then you can run it yourself. Or if you don't have any Python installed on your computer at home, then you can run this, for example, in Open Colab. So this belongs to Google. If you're not a fan of Google, you just click it, download it, and do it on your computer locally. Here, I will go through this example in Colab. So click here, and then you get redirected to this script. And we need a bit of patience. Here we go. So this is now this notebook, this Jupyter notebook open in Google Colab. So you don't have to install anything on your device if you don't have anything. If you don't want anything, just click on the link and it works. So the way the notebooks are structured is that there are different cells, sometimes with text and sometimes with stuff that you can execute. And if it's executable, then there's this little button here. Before you can do anything, you need to import libraries. Usually there is a set of standard libraries that's already installed, so you don't have to import anything. If you're running this the first time in this Colab, we will need a library that's called latlong23, and this is not part of the standard set, so you need to install it yourself. So therefore, click here and remove the little comment thingy, and then run it. And then it should run. So if outside Zoom, it's about in 10 seconds, everything is done. So let's see how long it takes during Zoom. Everything seems a bit slower. It's even faster. 9 seconds is set. So everything is prepared and successfully installed. So now we can run our checklist. So what we prepared for you is that when we do the data curation, then there are several misunderstandings, mistakes, typos that are occurring quite a lot. So we have created here a fake data set with basically the top 10 of the mistakes that we see very often. And therefore we decided we create a list of little functions so that you get easily get rid of these of the things that we call mistakes here. And so your data set looks perfect for submission. So this function will create you a whole bunch of fake data. So please don't submit anything like this. This is just for demonstration purposes. So let's create it. And so we have created something that's called DF, short for data frame. So this is actually a data of table. And we not only created it, but there we are also looking at it, and that's because we asked it for show us the head of this data frame. And if you ask for this, then you get usually the first 5 lines. So you see the header and you see the data. And if you have paid close attention, which I'm pretty sure you have, then you will see immediately a lot of things that where you think, this shouldn't look like that. For example, there is date and time in 2 different columns. There are some abbreviations most people probably don't know about. There is lat and long also in 1 column, and then it's not in decimal degrees. Then there is additional latitude, longitude, but here obviously somebody made accidentally a typo, so it's longitude. There seems to be a problem with the decimal separator because it's not just a point, sometimes it's a comma. And there are different parts or different types of missing values defined here. So sometimes it's a funny number, sometimes it's an n/a, but Python is recognizing neither of them because everything, so we have created here an empty column, so a missing value in Python looks like this. And we have comments in here, which also don't belong here. So let's check the data structure first. And we can do it by looking at our data frame again. And we are looking at the first 4 lines and the last 4 lines, and they're then mixed together in this function so that you get a nice overview of the data. So as you can see here, first 4 lines, last 4 lines, and we can see, oh, the last line is also full of comments which don't belong here. So let's start with removing rows that are not observations and don't belong to your data table. And this would be something like this. So in your data frame, the first and the last line will be removed. And then we have a look again at the first and the last 2 lines. Let's have a look. Here we go, the comments are gone. So let's check the data types. In theory, latitude, longitude, and all these observations here, they should be all numerical values. But if it's a mix of this, that's very likely. So it's a mix of numerical values and strings. So therefore, if you check the data types with the info function, then you can see it's all objects. Only the very last column, the empty column, was recognized as numerical values. So that's no good. So we need to clean up and get rid of the string values in here. So we start with remove all columns that contain nothing. So let's have a quick look again what it looked like. So there was the empty column with nothing in it. So we are going to remove it. And so we are dropping every column that is full of NAs. And then we are having a look at missing values. So if missing values are recognized by Python, they look like this. And then these are then not recognized, and these are strings. And so we need to tell them, well, that's not good, remove it. So we are replacing these values with nothing, so with an empty cell. Okay, so let's have a look whether this has worked. So let's have a look. And here we go. This is our column or our data frame. The empty column is completely gone, and where there has been the missing values, these are also now empty. So we can see immediately the next problem, that there are comma separated values in here instead of dot separated values, and it's in the column latitude. So we check the column latitude, and we want to find out or here we are showing only the unique values and the first 10 because it's quite many. Let's have a look, and there we see directly this is our problem. This is not going to work, and it's not recognizing this part as a number. So right now this is interpreted as string, or basically all of them are interpreted as string. And so we are replacing the comma in this column with dots. So data frame of the column latitude, replace the comma, and then let's have a look whether this has worked. And here you go. No commas any longer. So, but this is still a list of strings. So we need to convert it manually back to numerics. And we can do this either column by column by saying translate it to a numeric or convert it to a numeric, or we do it for several columns. And so in this line, we're doing it from column 6 onwards for the, so this part is left empty. So for everything that's followed after column 6, and they're all be converted to numerics. And then the DF info is showing us again whether this has worked. And here we go. So from column 6 on, it's all numerics. So what else do we have in our data frame? In general, leading and trailing white spaces are no fun and can mess up also again your data type. So we need to remove them. So yeah, whenever there's a white space, this is replaced with nothing. And we can look at the data format, at the date formatting. So that will be the next step. If we have a look again what it looks like, maybe not everybody remembers that date and time was in separate columns. So PANGAEA expects everything, so the date and the time in one column and in a so-called ISO format. And so therefore we need to merge them and reformat them. And if we look again, date and time have not yet been recognized as date objects or as date. So the format is not as expected. So it's not realizing that it's actually a date and a time. So it's thinking it's just some arbitrary object. So we can change that by saying the column date and the column time. We like to merge them together and convert it to something that's called date time. And then we would like to change the way it's written, so the string format of time, in a way that you have year, month, day capital T, and then hour, minutes, seconds. So that's the ISO format. And after we've done that, we can remove the column time because then we no longer need it. It's as easy as that. So, but that is already a big help if you submit your date time values as this. If we look further, what else do we have? We have our latitude, longitude in this way. So it's both in one column. That's something we don't want. There is the information of north and east. So this is something that you don't need to provide because we assume that you're using the format of the projection WGS84, and that means that everything that's south and west has a negative value. And it's not decimal degree, so this needs to be changed completely. So, but first we need to split it up in latitude and longitude in two different columns, and we can see here it's divided by a semicolon. So here we split it into two different columns. We split by the semicolon, and the first part will be stored in the newly created column lat, and the second part will be stored in a newly created column called long. And here we go. There is the lat and there is the long, and they are now nicely separated, but it's still in a format that we don't like. So we're using this little function. This is converting the latitude and the longitude to decimal units. So you need to give the format of what you have to start with, and you give the number of decimals that you'd like to see in the end, and you apply it to the latitude and longitude columns. And then you get these really nice columns with 6 digits in the end. So what else do we have? Let's have a look at these strings. So these are strings, they need to be strings, but what we don't like is that there are abbreviations. So this only means to a very limited number of people, and the rest is just looking at that, including me, like, I haven't got a clue what this means, so therefore we don't want it, and we want spelled out words. So spelled out abbreviations, you can do that by, in this case, this line is checking what are the individual or abbreviations all in the column threatened status. It's actually these set. So the abbreviated words are here in this list, and we like to replace them with the list of the spelled out words. So LC actually means least concern. And we can do that by replacing in this column the abbreviated words with the spelled out words. So there's no much thing that you need to do, and it works really nice. So we have one column full of species. And the trouble with species is, or species names, is that it's very easy to get typos inside. So therefore, we'd like to check whether there are any. And so we create a new data frame, which is called species. So we make a copy of the column species and we drop the duplicates. So that we have, as we can see, like dolphin or sailfish, that's in here several times. So we drop the duplicates, and so we have one list of the species in a new data frame called species. It looks like this. It's a very short one. And here we write it out in a text file. And if you use this Google Colab and you've just saved something, then you can look here. There is a little directory icon. And if you click on it, then you can see, hey, there is my species text. And actually there's other stuff, but I've just created the species text, so it's here. And you can then, you can click on download it. and then it appears in your download part. Here we go. And what we actually want,
immer noch die gleiche. Wow.
what you'd like to do is that to find out whether all the species names are correct, and we can check this via, for example, worms. So if you click here, you get redirected. Where's the mouse? And we get redirected. And we get redirected. So let's make this a bit larger. And this has a really nice function called taxon match. You can upload text files, for example, the one we just downloaded and created in species. Then you need to pay a bit attention of the fine print. So it's asking you for the row delimiter. And if sometimes you'd like to check that, so open it. And because we only have the row delimiter that's called LF, so it's only the line feed one. And if you forget to do this, it messes up the rest. And we have, yeah, and now we click on next. And we wait a bit. So it has found these three names, and now we wanted to match it. And it's telling you the first and the last one, they are spelled correctly, but the last one, that's obviously not known. So there might be a little typo inside. So let's check this little one real quick. And so it doesn't exist the way we are spelling it, but there are two very similar one, and we can find out that it's actually not, I don't know, what did we say? We said Dolphinus delphis, but it's actually Delphinus delphis. So, okay, now we can correct now our typo and continue. So in the original data frame, we are replacing the Dolphinus with Delphinus. And that's it. The parameter header was not as we want them to be. So if you need to, if you want to remind yourself a little how it's done, then you can look it up at our PANGAEA wiki page. There we have, or you can go to PANGAEA and first look for similar data sets to get a information of what your parameter might look like. You can also look at the wiki pages. There we have a whole parameter database, and you can check that one. Or if it's a geocode, then there's a special geocode wiki page, which I really like, but maybe we're running out of time. I'm not so sure.
No, we are not.
No, we're not? Okay. Because that one makes really clear when you're the geocode of the third dimension, what's it actually called and whether it's negative or positive. So for example, elevation that's above sea level is positive, elevation below sea level is negative, while depth water is again positive. So here's a really nice description that you don't get confused and everybody knows what you're talking about when you're submitting your data. So, but we can also use a list. So so as I said, there is a whole table of every parameter used in PANGAEA, and you can simply download it and open here and check it. So first you download it, and then you open it in a data frame that's called params. And we have a quick overview by looking at the first 4 and the last 4 lines. And so And you can see that the first two are actually not defined, but then you have something starting with numbers and you're ending up with Greek letters and things like water temperature somewhere in between. But we don't want you to search or, well, to look at every individual of these parameter names. That would everyone turn crazy. So we are lazy and we are having a little, we are using a little function. So for example, we would like to know all parameters that contain the word latitude and it's case insensitive. So go and search for us. And then you can see there's actually a really long list of several parameters that contain the word latitude. And the one we are actually looking for is the one in capitals. But in our example table, we have two latitudes. So we decide that we want latitude and latitude 2. Then in our in our example, we have this typo called longitude, where we forgot the O of longitude. So if we, for example, look for that one. Oh, sorry. Then, well, this is a very obvious one, then we won't find anything. And this is a very obvious typo, but sometimes, sometimes it's hard to spot where are the typos. So therefore, I recommend to use another function, which is called get close matches. So if you search for latitude and list only the first 10 matches, then you can see that it's not only giving you latitude, but also words which have very similar letters inside, but which actually have nothing in common with latitude. But if you have a typo and you're not aware of, like this, then this function is actually quite helpful, because then you see, oh, there's something with longitude and it's actually spelled with an O. So therefore you can correct your typo and get on with life. So after you've find all the correct parameter names, you'd like to replace them. So this little line shows you how it looks right now. So these are the column names of your data frame, and how well, and you can see that they are not as PANGAEA would like them to have. So for example, the unit is in the different type of brackets, and it's called date and not date time. So therefore, you search and find all the correct parameter names, and then you replace them by simply saying the column names are like this. So it needs to be, the list needs to be of the same length, and then you can simply replace them. And here you go. So your data frame now has a correct header. One thing that you should pay attention of, first, your water depth was in centimeters, but PANGAEA would like to have your water depth in meters. So therefore you need to do some number conversioning. So don't forget that, otherwise your numbers are all wrong. So in this case, we are converting from centimeters to meters. So now this is fine too. We would like to set some URLs. So we are creating a new column, which is called Uniform Resource Locator or Link to Reference. And we would like to give it this DOI or this UI. And we are not really sure whether this works. So we are checking it with this little function. And if it's correct, if the DOI works, then it appears now in our data frame. So here you go. And since this data was, or we simply assume this data was taken on a cruise, and so this was cruise number 132 of Polarstern, and all this data we simply assume right here has been created during this event of the number 1, -2. So we'd like to insert another column called event with this event label. And we simply do it like this. So now our data set looks really nice and shiny. We can save it and submit it. Okay. So, so much for the curation checklist. And we have one last slide, little summary of take-home messages. So be prepared, the author's guides are coming soon. If you want, or of course you want to submit your data, but if you do, submit it really as early as possible and no later than submitting your manuscript. Always remember to cite your data and include the full references. And please try out our templates. We think they're really helpful. If you don't agree, then also let us know. Don't hesitate to ask if there's anything you'd like further to know, or if you have any other comments. And a lot of information is in our wiki.